Hi, welcome to Unit 2. What we're going to do, we're going to go over chapters 1 and 2, and then you're going to see some examples, and then I'm going to make sure that I do a better job of it, just doing a basic intro to the studios so that we have a good jumping off point once we get there. Chapter 1 was just the intro and setup for Java. It talked about how to actually get started by downloading IntelliJ, downloading the JDK, all those kind of things. I just want to make sure that we have learned a little bit of vocabulary. The good news is, I think most of the stuff, I guess I forgot to, I copy and paste, so don't ignore that forms part. That was from our last one. But vocabulary is important whenever you go to job interviews, but to complete the course is not as important. So if you forget it in a couple weeks, that's fine. You just want to Google it before an interview. So JDK and SDK. So SDK, Software Development Kit, that is the generic name. So if you're dealing with Python or you're dealing with JavaScript or you're dealing with VS Code or whatever else, there's going to be SDKs that you will look up. That's generically any type of development kit for software engineers. JDK is just the Java version of that. So those things mean the same thing. It's just Java's more, JDK is just more specific for Java. So when you hear SDK or JDK, you need to know that those are development kits. Those are helping you as a developer in those languages. It did go into this weird thing about talking about Java C, which is the compiler command. I think it's good to know that in the back of your mind, that this is a compiled language, but it's also, I've never ran that in my life as an engineer. So you do not need to memorize Java C. That's why we have IntelliJ, because it's going to run that stuff for me. I don't need to do any of that. And then it is important for Java to understand that you do have a JVM, a Java virtual machine. What makes Java so much different than other languages is it's not just the language, it comes with this whole entire package. And you know how Windows is an operating system, Linux is an operating system, Mac OS is an operating system. Well, the JVM is technically an operating system. An operating system's job is to handle hardware on your device. So Windows, all Windows is doing is whenever you're clicking on things and doing all this stuff, yes, it's running some code, but more importantly, it's handling all the hardware. It knows what to send to RAM, what to send to the CPU, how to do all the connectedness stuff of the hardware of your computer. Well, Java, when it first came out, was a language that instead of running it just on Windows or just on Mac or just on Linux, they built this layer, this JVM, a virtual machine, right on top so that Java could always interact with no matter what operating system you had, because it was actually integrated with the JVM. And the JVM is the one that actually handled all those hardware connections and communication. So unlike JavaScript, which, based on the browser acts differently, Java, the main staple of Java was that it didn't matter where you ran it, it always ran the same way. But that's also because it's a compiled language that then is interpreted by this JVM, not by Windows or not by Mac or not by Linux. It's compiled and ran by this JVM. Again, you don't need to memorize all that. You just need to know that at a high level. Steps to getting started, like I said, it told you to install the JDK first and then the IDE. I think I told you last time, the simple way, if you wanted it fast, install the IDE and then go through the IDE to install the JDK. It makes it a little quicker. It connects everything and it downloads any different version you want, which as long as I think LaunchCode is using 17. Different teams have worked on use different version numbers. The subversion, like whether it's Amazon's or Oracle's or whatever else, we usually don't care too much about, but the actual version does matter, the major version. So 8 is still kind of around, but 11 and then 17. And to be honest, 22 just came out like a week and a half ago. So that's the newest version. So you can look at that if you really care about it. Java naming conventions, these are good practice naming conventions. We will talk a little bit more about package, not a lot more, but package is like your whole entire kind of not program, because you can have multiple packages in one program if you want, but package is a group of code. And a package is usually set inside of a directory. So those of you that were not seeing the package on IntelliJ, if you would have just added new directory, and as long as the naming conventions worked down, your IntelliJ would have known what you were doing. So directory and package, whenever you are starting something up, are almost interchangeable. It's just it interprets a package as a collection of code. And so you do need to have your directory structure set up in a way that IntelliJ knows what you're trying to do. But if you're doing package, it's all lowercase, no spaces, no hyphens or anything. Your class, so when we create a class, we do start with an uppercase, and it can be camel after that. So I think it's called Pascal case technically, but camel case is whenever you start with the lowercase and then every other word is capital after that. With your classes, if you have two words pushed together, they're both capital. So you start with a capital and then capital afterwards. Method and variables are camel case. You always start with lowercase, and then for every word that you add to it is a capital letter. And then with constants, those are things that don't change. You're going to do all uppercase, and you're going to put underscores. Because it's all uppercase, you can't distinguish between the words very well. So between the words, you're going to put an underscore between the words. You'll see those are still accurate with what I see in Java. And again, I didn't do a very good job editing. Don't worry about the forms. Right. I do, again, think that it's important to understand this compile process, but I'm just going to go over this and then we're going to keep going. You might want to Google this right before an interview or something, and that's only if it's in Java. Otherwise, you don't really have to memorize this, and IntelliJ does all of this for you, so you really don't need to know all the small details. But of course, we write code in Java. The code is passed through a compiler program and gets compiled. The compiler translates the Java into bytecode, which is a language readable by the JVM, so this more or less mini operating system that it sits on top of. And then the JVM, the bytecode is then translated into machine code that your actual hardware can understand, and then your computer reads and executes the machine code. So that's pretty much all of chapter 1, because the main thing with chapter 1, again, was just getting IntelliJ running and being able to push play and getting something to work. Chapter 2 is getting all of the resources you need, all the program files that we're doing. So we're going to talk about more Java-specific things, such as dynamically versus statically typed variables. So dynamic means that they can change. So Python is the biggest known to be dynamically changed. JavaScript is also one of those. But with those languages, if I say let x equal, and then I put a string there, and then later on I said x equals, and then I put a number, JavaScript and Python, they're going to say, okay, I'm just going to take your word for it. I'm going to do whatever you want to. I can switch the types as we go along. It doesn't matter. With Java, it is statically typed, meaning once you say that a variable is a string, it has to be a string forever. Once it's an array, it has to be an array forever. Once it's a double, it has to be a double forever. Now you can create different variables and change and like convert things, but you can't reset it to that variable. That variable has to stay the same type. So hopefully that makes a little more sense. Strings are immutable, meaning you cannot change them. There's a lot of things that we can do to strings, like on top of strings, and it does it temporarily. But if you don't save it to a separate variable, all your changes that you just did do not save to that old variable. So you can use strings. You can manipulate them in temporary memory storage, but the hard, like the long-term memory, it's not going to change. Single and double quotes. It kind of goes into this, but not really. If you saw me work in JavaScript, I always use double quotes because that's what I'm conditioned to by Java. Java wants double quotes for strings and single quotes for characters. That's just the normal process there. Naming conventions, I already talked about. But then primitive data types versus non-primitive data types, I have a picture and I'll explain more of the differences and or why later. But you do need to know that primitive data types, the easiest way to know that they're primitive is they start with the lowercase. All the lowercase data types are primitive, and all the uppercase data types are objects. So they get all these object methods and object things that you can now do with them. I will also talk a little bit more about like the auto boxing, unboxing, and boxing, and why we do that with a picture later. Hopefully that'll help you explain it. We did talk about importing, but we've imported things before, so I'm not going to go into a lot of detail there. And then commenting, it shows you how to comment. And then I'll reconfirm that it's the same shortcut in IntelliJ as it is in VS Code, which is Control / and so I'll show you that in live code. I'm going to answer any questions if there are. Yeah, I think people have been answering that. So the main reason why I like a language that says once you set it as a string, it's always going to be a string, is that anywhere I use that variable in my code, I know what I'm getting there. Versus if I can change it somewhere and then it loops through some other code that it was the other one, I don't know how it's going to interpret or respond to that. Okay. So these are just examples of some primitive data types. We have ints, floats, doubles, chars, like characters, and booleans. In my working, I have never used a float in Java. We had a little bit of a talking about this on Sunday. There was a few of us. I think the floats were set up to save memory space because they're a lot smaller. They don't take up as much memory. But I also think that it had something to do with like your operating systems only liking like a 32-bit operating system versus a 64-bit. Once you got more bits that a CPU can handle, now you can handle bigger numbers, bigger bits, bit sizes, bigger values coming through. So in my opinion, you will not use float. Just don't even use it. It's either int or double. And then a character is just a single character, and then Boolean's true or false. And then it does remind you that Booleans in Java are not capitalized because Boolean capitalized is the object Boolean, which I almost never use. It's always this smaller version there. These are all the string methods that you can, not all, these are many of the string methods you can do. Character at, substring. In my line of work, I don't do a lot with strings because I'm writing APIs. So all of the string manipulation is usually on the front end, which is your JavaScript and whatever else. And then once I get it, it's already kind of in a decent form. What I've done before is the trim function, the uppercase and lowercase, because I want to make sure that it's case insensitive, the contains, and then the equals. So those are the main ones that I use. I've used the other ones doing like LeetCode problems. So if you're one of those that wants to show off your LeetCode, you do need to memorize kind of all of those. The other thing that it talks about is scanner methods. Again, I don't do console scanner inputs, so I professionally have never written any scanner methods. Because again, they're going through the UI and then coming to me. So we'll talk about that at the end of Unit 2 on how I usually deal with these. But these are all the different ones. Some key things to think about: if in the method name it starts off with has or is, that usually returns a Boolean. So if it has next, it's asking, does this have a next value? Yes or no. So it's going to return a Boolean where like next int actually gets the next integer. So hopefully those make sense. So these are the questions I pulled off of Discord. Primitive versus non-primitive. I have a picture that I'm hopefully going to share with you for a little bit. Same thing with the boxing and unboxing, which is the next slide. Somebody asked about like main method, how picky is it? Well, the interesting thing about languages in general, went all the way up to about version 21, the main method absolutely needs to be the public static void main. Sometimes you can get away with not putting the string args in there, but you just do it. Like it just automatically pops in my IntelliJ for it. So you just do it. But Java, when it's being compiled, is looking for, where do I start this program? Because you just gave me, let's say I'm an enterprise application, you just gave me 3,000 files of code. Where do I even start at? And it looks for that main method. So that's really what you're doing, is you're telling it where is the very first line of code that I'm starting at, because you're not, it's not always at the top or per se, like it could be somewhere in your code somewhere. Somebody was asking, whenever we did JavaScript, we had to make classes with constructors. When you make instances of objects, you do want to use constructors. If you've noticed, everything that we've done so far is use the keyword static, which static means that I can access it without creating that object. That will make 100% more sense in a couple weeks whenever we get to classes, and I will hit it hard then. But you just need to know we are not creating instances of these classes. For instance, I don't have a person, and then I'm saying, hey, create a new person that has this age and this name and this whatever. That's creating an instance. So I'd have a person class, and then in my like runner class, I would have create new person and give it all of its parameters that I want. And now that new person has those attributes, where the person class is just a blueprint. We will get into that. That's the core of object-oriented programming. But right now we are using static methods, which static means that you don't have to do that. You don't have to create a person to then use the methods inside the person. It's static, so it just stays there. It's not changed. So you actually can't change the attributes inside there. You can use the methods though. You can use the variables, but you can't change them. Somebody did have a question about Unit 3. I think we went into part of it before, but I do want to just make sure there's a couple key things that I want to talk about. First of all, we have not really talked. We as like the IAs and Jamarco have not talked specifically about Unit 3 yet. Part of the reason why Unit 2 goes all the way to the middle of June. So we have a long time before we have to talk about those things. So the things that I am also thinking about whenever they ask me is, how should the groups be distributed? Should we think about virtual or in person? I can tell you, whenever I helped with an in-person one in Kansas City, the first thing I did was I surveyed the room and I said, what's most important to you? Like, do we want to split up that how many people can meet on Monday? How many people can meet on Tuesday? So we at least have a common time that we can always meet. Or do we want to meet in person? So, and that's actually what we did in Kansas City, is we told everybody, okay, here's Kansas City. How many of you live on the east side versus the west side versus the north side versus south side, or how many people live right in the central? And people started navigating to those. And we actually grouped them based on geolocation, because that was the easiest for them to meet in person. So they weren't driving 45 minutes one way to meet with people. They were all within about a 15-minute time frame. We will not be doing that exact thing with this cohort, obviously, because you guys are virtual. But what we might do is figure out, well, how many people never want to meet in person versus how many people want to meet in person, and then maybe group the in-person people together that are at least in the same city. With over 100 people, I mean, there's 123 people on this thing right now. We have a lot of wiggle room to do even different things. We will try to evaluate all of that when it gets closer. So probably June 1st-ish. we'll start figuring those things out. In my opinion, I do want to keep you guys in a location that's near other people, just so you have commonalities. But we're virtual, so do we have to? Probably not. And then I will go over more examples as Unit 2 goes on. So just kind of keep all of that in mind. We haven't decided. On the other hand, groups, you will have to work in a group. I don't know if LaunchCode particularly says that, but I will. Again, talking to Jamarco at the very beginning, I need to know that you can work in a group. And if you say, I individually created this project, that is much different than I learned how to use a Kanban board and use agile methodology to work and do project management skills with 3 to 4 other people to create this amazing project as a group. That's much more powerful. So I will make sure that you guys are in groups. Now, the group size will depend on how many and all those kind of things. So we don't know, but in a perfect set, I think probably 4 people in a group. It could be 3 or 5 or whatever else. Or again, we're going to have to talk through those things to figure out what's going on. So look at the questions before I go to live coding. So somebody else is talking about assignment 0. I'm not going to go over that. Don't worry about it. Turn in whatever you need to. Nobody's looking at it. Secondly, LeetCode. Just so you know, it is a common thing thrown out there. LeetCode just has a bunch of example code that you can go in. You can technically write it in any language that you want to, and it solves it has a situation. You guys are about to the level that if you wanted to start on some of the early LeetCode stuff just to get those refined skills up, that's fine. I had a weird thought for LeetCode. I do think that it can be used as a separator. If I have 2 candidates that are about the same level, it can separate them. On the other hand, I personally care about all the other stuff because I can show you my own code. I can work you through that. I also am a mentor, so like I care more. Can I actually mentor you rather than, do you already know all these fancy things that you can work in this one problem, but do you know how to translate whatever you did here to this real world problem? And some people have that disconnect where they can do LeetCode, but then I give them a business requirement and they're like, well, what do you even mean? I need people that I can give a business requirement to. You start thinking like a person, not just a computer. And then based on that, you can start coming up with ideas and flushing them out, which is much different than LeetCode. LeetCode gives you a very specific problem, which usually does not have a big business real world application to it. So then I don't even know. So LeetCode, though, some companies use LeetCode in their interviews. So for some of you, I would just at least glance there. You can probably start off with the easy ones. Are we going to do anything with command line arguments? I don't think we will. I mean, I know how to, but I don't think they're important. I've had to use them in some. In a Go application I had to write some, but I think that was the only time I've ever used command line arguments. So for the web, you usually don't need it. IntelliJ, why is it important that we see the time the code has been running? That's just for your benefit. There's a lot of things that, like if you're talking about scalability, like once I deploy this, I might need to know, well, has this been running for a full 24 hours? Has this been running for 9 years and never been restarted? Like there are metrics built in that is just there to your JVM. For this purpose of this class, you don't really need to know all those things. But again, remember, this is like an enterprise application where there's a lot of extra stuff for you. Yeah, thank you for posting it's LEET, LEET code.com. Again, not required for this course, but if you're just sitting there bored for 30 minutes to an hour and want to try one of those, I do think that it's kind of beneficial. But I think most of the other stuff is weather related. Here's the picture that I was talking about. This comes from the book, but it does a good example of showing. Can I write on this? Yes, I can. But now I can't erase it. Maybe. There we go. All right. So these things here are ints. These squares, the squares are locations in memory. So this is low level. This is not what you think about when you program. This is how the computer is thinking about this. So if I say int cat age 11, it's going to just store an 11 in memory. So anytime I go to first cat age and I say, hey, give me first cat age, it knows that it's 11. If you do anything with primitive, that's exactly what it does. It just pulls it. It's just there. That's what it is. Because objects do not have a defined size. So an int has so many bytes. After it gets so big, it can't store it. So because the computer knows that, then the computer can confine an int to this size in memory. Same thing with most of the other primitive types. But that's also why strings are not a primitive type, because strings can be one letter or they can be a whole 200 pages. Because it doesn't know the size, it switches it over to an object, and that's what happens here on this bottom part. So it's giving you an object of cat. Well, this thing right here, and what it's being stored in memory is a memory address location that points to the actual cat data. But this cat data that you can see on the right there, that can grow or shrink however it needs to, but it's stored somewhere else. The actual variable actually just points right there. So my cat, it goes here, and then it does a secondary lookup to the actual cat data. Now, in this example, it says that my cat is a new cat, and then same cat is my cat, because these are referring to the same cat. That's why these two are referring and pointing to the same box, even though each of these have their own section in memory. Again, you don't need to memorize this this is more like computer architecture type things of like memory allocation. The good news is Java does memory allocation for you. If you want to do something like C++, even Go, and those kind of things, you can use pointers, and there's languages that actually allow you to do manipulation of this memory. Java does not. Java says, you go program, you go use our fancy tools, we'll handle all this low-level stuff for you. So for those of you that wanted to know the difference between primitive and non-primitive, that's really what it is. Primitive stores the actual value right there, where non-primitive stores the memory location, and then it goes and gets it somewhere else. So that leads me to boxing, unboxing. Let's say I had an int versus an integer. An integer is a non-primitive. The reason for that is oftentimes I store it as an int, but ints don't have any methods on them. So then but I want to do something to the int, so I want to manipulate it using the integer class. I can do that. Java knows that we do that so often, so it has built into its core functionality that if you refer to an integer or an int, it knows those mean the same thing, and it knows how to go and grab the memory, do all the memory stuff. It knows how to do all that stuff for you. And that's why it's auto boxing, because it's doing it for you. And then you can manually either box or unbox. I never remember which one's which. I always have to Google it. But you can go back and forth between those manually if you want. But the whole reason for it is the memory allocation. Primitives store the value, but have no methods associated with them, where the objects have those methods associated with it, but store up more memory, so you go back and forth when needed. There is a way to open up an IntelliJ. I'll show you that. If you guys are still using Git Bash, do whatever you need to do, but you will never find a job that uses Git Bash. No company ever does. You just use Git from your terminal. I think that was my last slide. So expectations, attendance, studio, reading exercises, obviously. The only key point here, graded assignment 1, I'm just stating this because there was nothing else to state, so don't get too worried about graded assignment 1 yet, but it's due in 3 weeks. I will talk about it potentially on Monday next week. So you need to know what hash maps are. I think that's the latest thing that you need to know before you can start it. And hash maps are during class 3. So that'll be next, like a week from today, I will bring it up. So I will not bring it up on Thursday either. Do not worry about graded assignment 1. Worry about really understanding IntelliJ, really understanding some of these concepts. Remember, breaking things is okay. Do all of those things now so that whenever you're doing graded assignment 1, you can actually focus on graded assignment 1 and not, oh, I came across this error that hopefully you have come across already before. That's what I want you to do. Break things, come across errors now so you can focus later. Okay, there we go. The other thing I wanted to bring up here, this is the PDF that I'm going by. Fortunately for me, I don't have to go into Canvas for anything because I don't grade anything. So this is my kind of template that I go by. So today was chapter 1 and 2, Thursday's chapter 3, etc. So this Jamarco gave out a while ago. I think he pinned it in the general. So if you go to general and then go to the pins. And again, I think he put in Canvas all the way up to assignment 7, and that's because that's when graded assignment was. He'll put in more later, but that's all you need to be focusing on is up to that point. This is what I use. When you look through here, you'll see that we'll actually get some SQL stuff in here, which will be different, and then we'll have a week off for the holiday. And then, yeah, the last class of assignment or unit 2 is the 17th. There you go. Still a ways away. Just want to throw those dates out there. So the only thing I care that you know, middle of June is whenever assignment 2 gets done, or unit 2 gets done, and you go to unit 3, and then really, grade assignment isn't due for a little bit, but it is coming. Yeah, the textbook is old. They don't know what they're doing. So also, I would probably agree Windows command prompt would not be it. I would use PowerShell or the integrated terminal in IntelliJ. So I agree that command prompt, that I haven't used command prompt for ages. Ever since PowerShell came out, you're going to use PowerShell in Windows. Yep. And I don't know which one it is either, but I was going to say that. So you know how you do code to open up your thing? It's either IDEA, or it's IDEA 64. So instead of using code and then the file or folder, to be honest, you're going to do either IDEA or IDEA 64. And I can never remember which one's which. I unfortunately already have my stuff up, or else I'd kind of show you. At the very, very end, I might try it just so you can see it in front of you, but I know it is one of those. So I think graded assignment 0 is technically due today, but nobody is looking at it. So hopefully that makes a little more sense. Restrict only Maven or Gradle. So I at work use Maven. I am very comfortable with Maven, but LaunchCode uses Gradle. So all of your stuff here you'll actually see in Gradle. And so because you don't want to switch back and forth, I would just use Gradle for this, because it does mess with your mind whenever you're going through a build Gradle. So here's your build thing where your dependencies are here, versus in Maven, it's an XML, it's a pom.xml, and it's written in XML, which is the XML is the one that has like these things all over it. So that's your XML language. So it's just different. I've always just used Maven just because that's what my work always has done. But if you're using Gradle, just use the Gradle. We will talk about the dependencies later. So those of you that are wanting to know how this kind of works, I will talk about it once we need to mess with it. And that'll be once we go into Spring. So the Spring unit, we have to mess with dependencies. So we'll definitely do that. Other questions while we're just sitting right here. Anything in green right here is stuff that is needed for your thing to build, but you do not push up to GitHub, which is good because these files get kind of big. So these just go there. This has a Gradle wrapper, which is fine. All of your source code needs to be in this SRC. SRC stands for source. This is where all your source code lives. So this structure is very common where you have source, main, and then Java. You might have you'll sometimes have a resource folder here. You will not for what you guys are needing. Later, we will talk about a resource folder, but know that in the main is your main source. You can also have other things outside of main or the same level as main, but inside main, you usually have your Java and then your resources and or your other stuff. And then this is where all your Java code lives. And again, remember I said that when you're talking about enterprise, your Java code has to have packages. So our package here is org.launch, not org. These are actual folders. So it's, if you look at, can I open this up in? I'm going to open this up in my file explorer because this should be in LaunchCode. I know this is small for you guys. Don't worry too much. You guys will get the picture. All right. I know this is super small, but right here inside my data types example, you can see folders. I go into source, I go into main, I go into Java. Org is its own folder. So there's org and then LaunchCode is inside of org. If the folder is empty, it'll just do a dot so that you don't have empty folders in there. So that's why they do that. If you have, like in your package, if you have empty folders, you just do that. What else can I talk about? Just the structure. Your build Gradle is how it knows to build. If you go over on the right and hit Gradle, these are all of the different projects or modules that have the Gradle file. So this build Gradle says, hey, I have this Gradle project here. My project name is data type examples. So if you go over here, this data type examples is talking about these things here. When I look at the dependencies, I can go inside my Gradle build, and I can see that my dependencies, I have 2 of them. There's these 2 right here. So it kind of, IntelliJ matches all that stuff up, so you don't have to worry about that. And to be honest, LaunchCode skims over all of this. And it's because in the real world, like when you get a job, anything dealing with Gradle and anything dealing with all of these build stuff is already going to be done for you by your team. You aren't going to have to do new build stuff. Some senior, if something has to change, a senior developer or an architect's going to come in and do all this for you. So you need to be able to tie things together. But to be honest, you don't do this. Your team will do it as a team, but these things you won't really do. These are all the other files. A bat is for Windows, where this dash is for Mac or Linux. You don't have to worry about that. It has its own get ignore file so that it knows to ignore these types. So I think that's most of the stuff. LaunchCode has already done all the Gradle stuff for you. So when you did exercises, you had to create the source with the main, with the Java, with the org, with the LaunchCode, and then put your stuff in there. Where they already had all the Gradle stuff for you, because if they didn't, your stuff would not have ran like it's supposed to. So they did all the behind the scenes for you. I think that's probably it. I'm still going through some more. I'm just thinking about high level. Now I want to actually get into code. Yep, Git is still Git no matter what language you're in. I'll have to check the video to see if this is blurry, but I know that this is about as big as I can get. Because whenever I do Alt Control plus, it goes bigger, or Alt Shift plus. I guess I can get my code a little bigger, but I know these won't go any bigger because I know that they'll go smaller. So this is how I like it whenever I'm reading it, but I guess that's probably not good for you guys. So I'll make this bigger, and I guess I can make the code just a little bit bigger, especially once I get into it. I'm also wondering if having 128 people all attached to the same thing messes with the blurriness. Okay. Okay, so somebody asked about you can, if you go over to the left, there's commit. So anytime you have a commit, you can actually click on all the changes that you wanted to add, and then you put in your commit message here, and then you can hit commit, and it'll actually do a commit for you. IntelliJ has this kind of built in. You can also commit and push. So when you do the commit, it'll separate those two. It'll do the commit first to make sure you want to do that. And then after it commits it, it'll say, you said you wanted to push, or you sure you want to push? So you can use these. I'm not, to be honest, for work, I actually do these. There's also a Git thing in the bottom. Some of you might have yours around differently than mine, but there's a Git. And so then I can say I only have one branch, which is my main branch. And if you click on like the log, it'll tell you every single commit that's ever happened to this. I wouldn't use the console. The console kind of runs when you click on things. I just do what I did in VS Code though. So instead of worrying about all of this, and to get you guys more familiar with the terminal and with these commands, I just open up the terminal down here, and I do all of my Git commands right here. So this is where I would do the Git add. So as you can see, there's a bunch of unstaged things that I have. And that's fine. I mean, I'm not going to probably push mine. But you can do all of your Git stuff right here. This is where I would do it, which in the bottom it says terminal. I think you could, I don't know where the terminal is here either. Up at the top, there's also Git commit and push and all these kind of things here. Again, if it was me, you need to get more and more comfortable with Git. So I would just do the terminal down here. That would be my preference. But again, once you join a team, they're going to have their own way of doing things. And as long as you can get your code where it needs to be, nobody's going to have a concern with you. But then whenever you have a problem, they will tell you exactly how they do it. They don't care how you do it. They're going to tell you how they do it. And either you can do it that way or Google and find it out on your own. So if you were on my team, I would tell you to just do all the Git commands straight from here. Unlike JavaScript, we do not run our code from the terminal. One of the reasons why it has to get compiled before it runs. So instead of doing that Java C and then typing in some kind of file.java or whatever else, I don't want to have to do that. So IntelliJ makes it so I don't have to do that. So the terminal, I can make that go away. Let's go ahead and close all my tabs. Let's start somewhat fresh. Let's go to, what time is it? 6:30. Okay. In the examples, I'll come back to, I made something that I want to show you if we have time. Let's go to the exercises first. In the exercises, these are the codes that were there. First of all, you were supposed to do a new scanner. It keeps telling you that you need to import things. IntelliJ should take care of that for you. So I almost never, I do sometimes when I want to get very specific, but I almost never import anything and actually type out the import. I just type out what I want and then it auto imports. That's the cool thing about having an IDE like this. Again, with structure, your package needs to be there. Your package has to match the directory structure. That's what I was saying. Those two are connected. Your package and directory are the same thing, because what this is saying is this thing here lives in org.launchcode or org/launchcode. And you can see here, it has a whole bunch of package things that it can do. So if I reference hello world somewhere, it's going to import it from org.launchcode.hello world. So it's just the file location that it's at. So package and directory mean almost the same thing at the level that you guys are at. The interpreter, the compiler does something different with it, but for you guys, it's the same. Again, with the imports, I just import it. And again, remember, we need the public static void main string args. Those of you that are like, I hate this public static void main, what blah, blah, blah. Java 22 that just came out actually got rid of all of this. I think now you can just say main or public main, and it just knows what your main class is anymore. So Java 22 is trying to make it more like, to be honest, Kotlin. If anybody's done Android development, it's trying to make it more friendly for new developers. So yeah, see, my zoom only goes to 200, and that's as far as this thing is. So like I have zoomed it in all the way. I think my code can go up to, my code, instead of doing a percentage, does a point, like however many point fonts. So I can zoom in code more, but I can't zoom this anymore. Don't have a build folder. Trying to also keep up with the things. Unfortunately, this is the part about having virtual classes is my screen is super huge. Like I have a 27-inch screen, so I know that this is going to be big, but I think I'm just going to have to keep going. But I know that this is as big as I can get because I spent like 30 minutes trying to figure out how to get this bigger, and it won't get any bigger than that. So a question was string name, input next line. I don't know. Could we also write string name in line 10? I don't understand the question, so if you want to restate that. Yeah, the problem with Discord, it only allows me to have 25. So which 25 want to view my teaching? Discord, unless if I think that we can pay for it, but LaunchCode is not going to pay for it. So I've also thought about that. Plus, also, I don't know if you guys have had this, but my Discord is actually way more blurry. And I've actually had Discord just shut off on me before because I'm trying to stream. So on this, I also know that because this is making a video from my screen, the video on YouTube should be fine too. So, this was just the basic one. I named mine Hello World because I thought that's what we were supposed to, but then when I looked at some kind of answer key, I think it said like input output. I got confused on what they wanted me to name this because I thought they were talking about both things both at the same time. Welcome to LaunchCode curriculum. So whenever I run this, the first thing is if you don't see these green arrows here, that's when somebody said, and I can't remember which exact file I needed to type on. But if you do the make this source or something, it's in the book somewhere. But if you do the, I don't ever have to do it, so I don't know what it is. But it's like make this the source, like the root. I think somebody saw that. Somebody posted that if you make it the root, then it does that. To be honest, I think I showed it last time. Whenever I imported, there was a box over here that said, hey, you have lots of stuff in here. Do you want to import them all? And I said, yes. And then somebody else noticed that it did all of these for me and it tried to import them. And when it does it the first time, it takes forever. So when you hit that button, you just got to kind of walk away from your computer for a couple minutes and then it pulls it all in. And now it allows me to see all the green arrows that I want to see. So yeah, please stay safe with the tornado stuff. Around here, it was thundering kind of bad, but I guess in St. Louis, it's really, really bad. All right. I guess we'll go out again. So how do you print to the console? You do system out. System means like your operating system, like your computer. Out means you're wanting to push something out, and then you're wanting to print this line. Hello, what is your name? The other one, I don't know if the book talks about it, but I use just print sometimes. Print does not do a new line at the end, where ln does a new line at the end. So I'll show you the difference. If I run this, I have cap locks on. All right. And then the string name, I'm storing the actual input of the next line. Well, it doesn't have a next line, so it waits for me to actually put in the next line, and then it'll print this out. So if I do it with the new line up here, and I hit run, I can hit these runs, or if you change this to just current file, then it always just runs your current file. That's what I usually do. So it'll say, what is your name? But whenever I type this, if you see, it actually prints it. It actually tries me typing on the next line. And then when I hit enter, if I didn't mess, It says, hello, Philip. It took a little while to respond. Sorry about that. But so it does this where if I do not next line, do you see how the cursor stays on the same line as my print, because it didn't do a next line for the input, it stayed on the same line. So I like doing this. So I don't always do next line. It's just personal preference. So just know that that's there. LN is new line. I think they had this thing with miles per gallon. I took this off the answer key. They did a capital letter double, where I did mine as lowercase doubles. I think either one should work. So when I do this and I run it, it's going to say how many miles have you driven, how much gas did you use, and then it's going to do the miles divided by the gallons. So if I run this, how many miles? Let's say 100. How many gallons? Let's say 4. If I did the math right, yep, that should be 25 miles a gallon. The rectangle is the same way. You just do length times width. If you do notice on these, instead of saying next, it is very good to point out that when you do next, it should throw an error right here. That's because next gets you a string. It does not get you a double. So if I did string here, then it says, well, this is fine. But then down here it says, oh, you can't divide a string by a double. You can't do that. This is the power of JavaScript with strictly type. Because it's strictly type and it has to be, your IDE picks up all of these errors for you, so you don't accidentally have these errors later. Also, in JavaScript, if you remember, sometimes it would automatically change like a 25 from a string to a number, just depending on what the circumstances was for you, where this is not going to do that. You said it was a string, it's going to treat it like a string. Yeah, the public static void main part, yeah, Christian did have an article that explained it if you needed to, but really what it's doing, I guess I'll explain the individual parts a little bit better, but the actual, this thing as a whole is telling your program where to start at. If you don't have it in that format, the program will not know where to start. It knows that you have code, but that tells you where to start at. Yeah, and again, I'll tell you a little bit. Yes, public allows it to be seen in other locations. Well, when I'm dealing with the main class, that doesn't really, main method, that doesn't matter as much. But public means that it can be accessible, and main needs to be accessible. So that's why it's public. Static means that I can call it. We have enough time. I'll do that instead of going deeper into some of this other stuff. I'll show you a little bit of how static works versus not static. Void is when you create functions, you have to tell what data type is going to get returned from the function. In Java, you have to do that. So you will always have usually a method that says public or private, and then it's a data type. You won't always have static, but you'll have a data type. Well, main isn't going to return anything, and we are saying, hey, it's not going to return anything. It's just going to be void. There's nothing going to get returned. So the void means nothing is going to get returned. And then main is the name of the function. So hopefully, to sum what I just did, next does strings. So if I keep this as a double, it's not going to like it because next the thing. I could technically cast it. So there's stuff like this, but that's not going to like it. So then there's methods on double that says value of. So there's things like this where double value of. There's also parse double, I guess. There's all these different methods on how to do this. The only reason I bring this up, do you see how double has a capital and parse double here? if I control click on this, this is also going to be a static and it's also going to be public. The reason that's important, public means that whenever I'm in this thing, which is the double class, I can view it in the miles class. So public allows me to do that. The static allows me to not have to create a double object first. I can just use it. And then double is the data type that it's going to return. It's going to return me a double. The input has to be a string. So that's what all of those are. And to be honest, we will go over this several times because that's the most important thing you can get out of Java is how to set up methods. So I could do something like this and it would still work because I'm getting the next thing. The only problem is if I don't type in a number here, it'll throw an error. It'll say, hey, I can't parse XYZ. I can only parse numbers. Right. The only other thing I wanted to show you was on this thing, Alice. So I did Alice. The book said it, but it didn't really state it very well. Where if I have, let's say I want to break this line apart because I don't want it sticking over so far, I can just go somewhere and hit enter, and IntelliJ will naturally, for me, put this plus sign and put it on the next line for me. So it is perfectly fine if something is too long, you just go where you want to go on the next line, you push enter, and it's still, IntelliJ does that for you. I make a scanner. I say, what word do you want to search for? My search word is whatever the next line is. I could also do next here if I want to, but it's going to give me a word. Now, I want to say, is this search word in the string? And most people are fine with that, but people were confused about, the method chaining. Here we go. I did this on purpose for all these method chaining. I'm taking Alice, which is all that text up there. I'm going to switch it to lowercase. This temporarily switches it to lowercase. Remember, strings are immutable, so it doesn't actually change everything to lowercase. It just looks at it, it changes it to lowercase and keeps that in working memory. And then it asks, does it contain the search word that I just typed in also on lowercase? So if I run this and I say, Alice, it'll say, is Alice in the string? And it'll say true, even though Alice is lowercase here, but Alice is uppercase up here. Just like if I did was, I can do was all in capital, and it'll say true. Because I do want to get to something else, I'm going to copy and paste kind of what I had before. So the problem with doing this to lowercase, the problem with it is if I only want to use it once, the to lowercase is probably the best option. But the task 2 in this was to then also get the index of that search word. So now, if I want to get the index of where that search word is, I have to do the to lowercase every single time I do anything. And so this works. I've tested it out. It works. The problem is I have to do all of these to lowercase, to lowercase, to lowercase. So if you're going to do that, the better thing to do is to take your string and just make another string. And I'm going to call it Alice lowercase equals, and then I'm going to say Alice to lowercase. Now I'm actually having 2 different strings. I have my original, and then I have my Alice that's lowercase. Again, I didn't change Alice. I can't manipulate Alice, but I can temporarily change it and then save it to a new variable. And then instead of using all of these 2 lowercases, I can just say, now I have this new string that's Alice lowercase. I can do the same thing for my search word. I can say search word, and I could just do, I could just make it lowercase as soon as I grab it. Or I can do search word and then search word lowercase and do it on 2 different lines. Yeah, when you're talking about keeping it dry, yeah, if there's something that you're doing over and over again, you find a way to not do it over and over again. So absolutely. And again, when we talk about writing code, if you write, you are supposed to write bad code when you first start. It's if you aren't writing bad code, that usually means you're cheating somehow. So I need to see bad code first, but then your thought process is, okay, I wrote this bad code. I know it's bad code. Now let me try to make it better. So I still want you to realize it is absolutely normal to write code that is not concise and small in hopes that then you'll start writing more concise code after the fact. So last thing before I go into studio. I'm reading a book right now. I don't want to say the exact words of it because it's probably not appropriate. Just the header is not appropriate, but the book is really good. And it more or less says, if you are better than somebody else at something, it's usually because you failed more times than they have. And if you're not as good as somebody, it's usually because they failed more times than you have. Because real learning comes through failure, and that really hit home with me because that's exactly what it is. You have to try, fail, and then it comes. So I might type it up somewhere. I might put it in the book channel at some point. All right. Here's what I'm going to do. Okay, I'm going to do something. I'm going to show you something. This is not this lesson, okay? This is because you guys have that inquisitive mindset, which is amazing. So I want to preview something and show you something, but this is not for this lesson. So if what I say right now, it makes no sense to you, that's fine. It's fine. I'll talk about it more in depth later. So this is what I was talking about with static versus not static. So let's say that I just made a function. I'm going to consolidate this. I was going to do something more, but I'm not going to. So let's do. Okay. So I made a class 1 function. I called now this is a class. This is not a function. And then I said, I made one method in there that says run this. Now, again, if I get rid of void, it says, hey, you have a problem. I like how it tells you have a problem. And it says that this problem, it says, hey, you need to make it return void because it's not returning anything, and you have to tell it what it's returning. So I'm saying, okay, I'm running void. That's fine. And then this is going to run this thing. So whenever I go back here, my static void, remember, this is telling it where to start. If I look over here, do you see how there's no green arrows? There's no green arrows because this is not a main function. You have to tell it where to start at. You can't just run a class to run a class. You have to run a main function to start. So with this, if I said, hey, I want to run this, like that's what it's called over here. It's called run this. And I go over here and it says, hey, I don't know what that means. And so I go over here and it says create method in this class. No, I already have it somewhere. I don't want to create it. So how do I get this to run? Well, because I made this not static. Well, okay, so let's make it static first. If I make it static, I can actually run this. And it says right here, import static method here. And I said here, I'm importing this static function right here, and I can actually run this now. If I didn't put the static, in there, There was no way, like this says that I have to create a method right here. This, the private meaning internal, like, do you want to run this right now? And let's say, well, I wanted to run it off of class one function dot run this. I think that's what I called it. Yeah. And it says, hey, this is a non-static method. You can't use it here. So that's hopefully trying to prove to you what static is. Static is whenever you're trying to get a method from a different class. Now, that's one way to do it, is to make it static. The other way is to create an instance. So this is my class one function. If I don't have it static, what I can do here is I can say, hey, I have a class one function object that I'm going to say C1F, just for short, class one function. And I'm going to say, hey, create a new class one function. What this does is it creates in memory this object, and this object has the blueprint of this. Now that I've created an object, now I can call upon that object and say, hey, and it actually pops up for me right here. It says, go do this. And then when I run this, it says this class is fun. So if you have a static method, you can call that method outside of that class without setting up a new class, setting up a new object. If you make it not static, then you have to create that object first to then run that method on. And again, class 4, I think, goes over classes. So I will go over this again, not Thursday, but the Thursday after. So again, I just talked about something that you don't need to know right this second. You just need to use static everywhere, and most of the time it'll work for what you guys are doing. And even here, do you see how I don't even have to import it if it's not static? Because it's not running it off of this class, it's actually running it off of this object. So it's going and finding the object and then going and finding the method inside that object. All right. Any other last minute questions before I turn the recording off? Actually, I told you I was going to do an intro to Studio. Here's the Studio for today. It's really nice. You are going to create this source folder, just like you did in the exercises. So if you did the exercises, today's Studio is amazing. It's just reconfirming what you did in your exercises. If you did not do the exercises, you'll be lost, and shame on you, because you need to do exercises before you come to class. But you're going to create some different things here. I don't want to show all the code as much as just run it. So I'm going to run this. When you run your area class, it should ask you what the radius of your circle is, and you're going to have a circle class that's going to be that's going to have a static method of creating the area for you of a circle. So what's the radius of your circle? I could say 5. And then it's going to say, I entered in a double. Well, okay, so I did all of them, which does validation of, did I enter in a double? Is it positive? All those kind of things. So I put some if statements in there. But then your area, it should give you the area is. So if you do the first one, you won't have that middle part there. You'll just type in a number and it'll have the area. To validate this, hopefully you guys know with a radius of 1, it's pi r squared. So 1 times 1 is 1 times 3.14. Should be 3.14. What I did, I brought in the math.pi that I think the book talks about that, where there's a math dot, and you can use any of the math methods because they're all static, and you can use the variables because they're static and they can be accessed outside of that class. So instead of using 3.14 like the book does, I used math dot capital P, capital I for mine. That's why mine's this huge long number there. So Hopefully that makes sense on what you're doing, creating two things, getting some input, throwing it into a circle that has a dot get whatever. I created mine different. I created mine way different than what you needed to. So I'm not going to show that, but that's your studio.